In this video, I will give a very quick review on how to position a point in Cartesian coordinate system. So let's take a point. Suppose our point is P, whose coordinate is -1, then 2, then -1. So let's draw it. First, we have to take a three-dimensional axis system. Suppose this is our three-dimensional axis system. So let's place our x here. So consequently, our y will be placed here and z will be placed here, right? So now what we have to do first is to place the point. So the first for x is -1, y is 2, and z is -1. So for x, we have to take 1 unit, but as it is negative, so it will go to the backward half. So for x, suppose this is 1 unit. So x, this is 1 unit. What about y? Y is +2, so we have to take 2 unit, but on the right half. So we have to take 2 unit on the right half. Suppose this is 2 unit, so this will be along the right half. Now what about z? Z is -1, so we have to take 1 unit, but it has to be in the downward half. So it has to be in the downward half in 1 unit. Alright, so what we have to do first, that we have to draw the projection point along the horizontal plane, that is here the xy plane. So let's draw the projection first. So to draw the projection, let's place our ruler here and draw a parallel line with respect to y-axis. So let's draw a parallel line with respect to y-axis. So I think it is parallel with respect to y-axis. Alright, so this is a line which is parallel to y-axis. Now let's draw a line that will be parallel to x-axis by keeping our ruler here. So we have to rotate our ruler to make it parallel to x-axis. So let's make it parallel to x-axis. I think it is parallel, right? So now draw a line that will be parallel to x-axis. This two line where gets intercepted is the projection of our intended point, right? So this is the projection. So the projection point should be -1, then 2, but no height, so that is 0. Now we have to include the height. To include the height, let's place the ruler at the projection point and then draw a line that will be parallel to z-axis. Now let's make the ruler parallel to z-axis. I think it is parallel, 90 degree, right? So let's make a line that will be parallel to z-axis. Now, but our z-axis is only 1 unit downward. So to ensure that, what we have to do is that we have to place our ruler here and we have to draw a line that has to be parallel to the projection line. Who cannot remember what a projection line is? Just make a very quick view. Projection line is the line which is drawn by joining the projection point with origin. So if we just join our projection point with origin, then we will have our projection line, right? Okay, so just join our projection point with the origin. So I think it needs to be rotated a little bit more. I think it's good enough, right? So let's join the origin with the projection line. So this is our projection line. So what we have to do here, we have to draw a line which will be parallel to this projection line. So this is parallel to the projection line. So this line where intercepts our previous parallel line is our intended point. So our point is -1, then 2, then -1. So to draw the vector, what we have to do is that our x is -1, so x will be pointing backward. So here, if we want to include the vector quantities or vector directions, then our x will be pointing backward. So this will be the direction of x. What about y? Y is +2. So as y is positive, it will be pointing towards the right. So it will be pointing towards the right. What about z? Z is negative, so it will be pointing downward. So z will be pointing downward. To have the total direction of the vector, we have to join this P point with origin and put a vector direction going out of the origin. So let's rotate the ruler. And just join these two, origin and P. I think it's not good. So let's make it more closer. I think it needs a little bit more rotation. I think it is good, right? So let's join this 2 point and let's give a vector direction coming out of the origin. That's it. We have given a quick review on how to position a point in Cartesian coordinate system and express it in a vector quantity. Thank you.